So first we can go to the direct shear stress. First one is your direct shear stress. What is the direct shear stress? So how it is defined? Defined as tau. Defined as tau. That means if this is one element, over surface, you will apply as tangential force, then you will apply a tangential force. What will happen? This element will try to slide, the upper element will try to slide. Now this particle have bond energy of both. They are connected with each other by some bonding. If they are having bond, that means if this one will try to move, obviously the lower layer will also try to move along with it. So here it will be deformed. Correct? So if it is deforming, that means after this much amount of load, obviously the element has resisted all the tangential force applied to it. जितनी tangential force apply कितना सब पूरा क्या resist कर दीजिए? All the force is resisted by whom? This element. अरे ये सब ना? Resist करीची बोली तो एक position अच्छी. Otherwise it must be flow. यदि resist करी ना तो then fluid है ना वो resist करी बड़ी मैंने सिर्फ तार continuous flow ही चला. अरे ना भाई. As you are exerting a force, tangential force of a fluid, it will continue to deform. But here it will not deform continuously. Are you getting this? So it is resisted. It was resisted. Resistance means it has resisted. So whatever the intensity of resistance occurs, that is called as the shear stress tau. So this tau is equal to how much? Resisting shear force dividing the cross-sectional area. Are you getting? Cross-sectional area, which cross-sectional area? How cross-sectional area? जो भी अप्लाई कीजिए, कोडी अप्लाई कीजिए, तो दिस वन इज द सदर एलिमेंट. तो इधर इधर cross-sectional area, इसका cross-sectional area. कोडी अप्लाई कीजिए, ऊपर सरफेस पर अप्लाई कीजिए. हमारा tau is equals to shear, that is resisting force tangential divided by cross-sectional area. Unit का जो what is the unit? Newton per meter square or Pascal. So this is your direct shear stress. Direct shear stress में करा हुआ है whenever the load is applied normal to the surface पर direct है. Next we can go to the indirect shear stress. Indirect shear stress. So what is indirect shear stress? That means directly the load or tangential load is not applied over the surface. Surface ऊपर हम directly load apply करते हैं. But there is shearing occurring between the elements. ठीक है? That means the tangential force, the load is not applied over the surface. Rather, but as shear stress is generated between a layer, between layers at a distance. At a distance, the layers would have been the shear stress. Example, what is the example? Example is the torsion. Torsion? What is the torsion? E by J is equal to D by J is equal to G theta layer is equal to tau layer. So if suppose this is a plate, let us plate layer. There is a rod, circular rod. If you are applying a twisting moment, a T, what is the meaning of twisting moment? Twisting moment. How to define twisting moment? bending moment. How to define? Twisting over the surface, bending at the middle. But beam or the load apply then it will create bending moment. Over the surface, if you are applying to rotate, that is called as the twisting moment. If you are applying a twisting moment T, then what will happen? So this will try to rotate like this. So this element, fluids nearer to adjacent element. What will you do? This element will experience shear stress. What is the shear stress here? Or it will shear in here. Correct? So here you can say this element, which is at a distance, it will experience A element. This A element will experience shear stress. Shear stress. It will experience shear stress. That means the load directly on this load is not applied over this element, but still shearing element. That is why this is called indirect shear stress. How is that indirect shear stress? So this is G by J is equals to G theta dividing by L is equals to tau dividing by R. So here you can say this tau is the shear stress. So T by J multiplied by R is the tau. And whatever this tau is generated, a tau developed, that is called as the indirect shear stress. So this is the torsion formula. You will study that. You will study the torsion formula when you torsion. Stress कितना करना stress is your utilized one is your normal total of power one is your normal stress और direct stress normal stress direction to time direct and indirect ये भी कौन direct and indirect which one is indirect normal stress bending which one is indirect shear stress torsion twisting bending formula कौन था so we will study that bending formula देखिए अंदर में आता है bending formula twisting formula এটা নিহাতি দরকার সমস্ত ঠিক আছে bending formula করা m by a is equals to sigma by a is equals to tau by m by a is equals to sigma by y is equals to e by r torsion formula করা e by j g theta by l is equals to tau by r what is stress what is your force जोड़ा पचल stress is not a vector. Stress is a vector. True or false? Obviously false. Stress is a tensor quantity. I is a tensor quantity. What is the meaning of tensor quantity? We can say vector means one magnitude must be there, one direction must be there. Correct? One magnitude and one direction. What is a tensor quantity? Tensor means if it is having one magnitude, but it can have multiple directions. I am saying, I am pulling this body. Correct? Here I am applying the force. Now the particle which is experiencing the force, it is connected to adjacent particle. Where it is connected? So if this is the particle, it is connected with this particle, it is connected with this particle, it is connected with this particle. In 3 dimensional it is connected. That means, see here, mapping this is a net. Okay na? Net jala. What point to the return of the pole is used? The conical section is. What is the meaning? That means all the particles are connected. Then the resisting force will be due to all these connections or all these particles which are connected. That means the resistance which is offering the body, that is not by a single direction, not over a plane, it is not over a particular direction. That means the stress which is occurring, whatever the resistance, you are giving a force of F here. Here this is the resisting force. That means this resistance is not from a particular direction. This is from the space. Space means what? Three-dimensional object or three-dimensional space. That means more than one directions. That means stress is not a scalar quantity. Stress is not a vector quantity. Stress is a tensor quantity. Are you getting so? Tensor quantity वाला केमिति represent करेंगे? How to represent the stress? And three-dimensional केमिति represent करेंगे? How to represent stress? How to represent stress? So, stress is a tensor quantity. Tensor quantity. What is the tensor quantity? One magnitude plus more than one direction. One magnitude and more than one direction. That means over the element it can be represented the gote element upar multiple direction ru stress develop he pare. Suppose this is x axis, this one is y axis, this one is y axis, this one is your z axis. I am taking a cube here. This is x-axis, this is y-axis, this is z-axis. Suppose this is a unit cube. Stress is a tensor quantity. That means here there must be a stress. What is the stress here? Normal stress or shear stress? Normal stress. It can be represented as sigma. Now here this is along y direction. This can also be sigma. Which one is the z direction? This one is x, this one y, this one is the z direction. Sigma. Correct? But direction is same or different? Different. So always stress or sigma, whether it is sigma or tau, it is represented as two quantities. Suppose this is x. What is the meaning of this x? Or basically we can say, so stress represented by suffix x. I am taking xy. What is the meaning of this xy? It is the face or plane. This one is the direction. Plane, or we can say face. This one is the direction. Okay. So a plane is defined as plane को कैसे define करा जाए? The perpendicular drawn over the surface. तावले एक प्लेन को कैसे डिफाइन करेंगे? The perpendicular which is drawn over the surface. तावले एक प्लेन को कैसे डिफाइन करेंगे? Axis है और this is x face. This is ना x face. In which direction? X direction. X. This one is in which direction? Y direction. Y face होता है ना perpendicular के अच्छी y अच्छी. So y face along which direction? Y direction. Correct? This is in the z face. In which direction? Z direction. X, Y, Z. This is the number of stress. What is the shear stress? Shear stress co-direction shearing है करियो over the surface. A direction नहीं करियो, A direction नहीं करियो. So one shear stress is along this direction. This one. Another one is along this direction. It can be this direction, it can be this direction. Whatever will be. Correct? What will be this stress? Either one नहीं करियो. Tau. Which face? Which face? X face. Which direction? Y. This is x. This is y. So this is y direction. So x. Y. tau xz, this one is tau xy. Here we can take this one, another one is this one. Correct? What will be this one? Tau. Which phase? Y phase. Which direction? X direction. This one is tau. Which phase? Y phase. Which direction? Z direction. Correct? Here we can take this one. Tau. Which phase? Z phase. This one Z phase, no? Which direction? Y direction. This one can be tau. Z phase. Which direction? X direction. That means this is the representation of stress. तो केमिति रिप्रेजेंट करबो सो सिग्मा इज रिप्रेजेंटेड बाय a matrix. So here we can say sigma x or xx, tau xy, tau xz, tau yx, sigma yy, tau yz and xy z ना हां देखो देखो xx xx xy xz yx yy yz तब तक समझो tau zx tau zy तब तक समझो sigma अरे रोजे ना zx zy sigma zz sigma yy sigma xx ठीक है. So the diagonal of the stress matrix is the diagonal of the stress matrix is normal stress, or we can say normal stress. This one is called as shear stress. So this is shear stress. So remember this one. Shear stress. So what element पर stress को भी कोई x axis रे y axis रे z axis रे एडी कौन हला sigma xx x direction start करेंगे sigma xx तब कौन हला tau अछि आउ x direction को स्ट्रेस अछि x plane ऊपर को स्ट्रेस अछि tau xy अछि tau xz अछि तो डायरेक्टली sigma xx तब y x plane रे रहबा दरकार. This is over x plane, this is over y plane, this is over z plane. First देखिए x plane x direction और x direction sigma x x tau का x plane over y direction, tau over x plane and z direction. Second है second है y plane को आएगा this is y plane sigma y कौन हो y direction है तो मध्य देखिए कौन अछि एबे x direction कौन अछि first x y z ले बुझलो this is x this is y this is z कॉलम. So tau कौन है y along x axis, so tau yx तापर कौन है sigma x का मतलब कौन है y is, so then it is sigma y तापर tau yz तापर कौन है tau y का zx और zy and tau z. This is the representation of stress in unit.